Welcome to the lecture series on object oriented analysis and design. So, we are talking about object oriented testing. What is the essence of it? The first one is it has given us a seamless way of looking at the entire life cycle by making system, unit and integration testings appear together along with the concepts of polymorphism, inheritance and encapsulation. So, we were banking on these ideas primarily in object oriented testing, seeing how through the state, method and therefore, the identity of the object, we can very quickly do this object oriented testing. We accept black boxes, we work with broken systems and then make them happen together. We know how to knit. There is a definitive possibility of using ideas like interface definition language, ORBs, object request brokers, common objects. So, the things are everywhere anywhere, the components are everywhere anywhere, the ideas are there, we can put them together, but how much of success is happening in this area? Only two great successes of very specific variety, the cloud, that is service oriented architecture variety, namely the cloud and then the web services to some extent. But however, plenty of ideas were there, limited implementations are possible, it is doing well, they are very promising, they have attained a level of maturity. But then once they hit the peak, we are going back to this idea of common object request brokers. We are now talking about things, millions of things, zillions of things. How do we work with the next idea called Internet of Things? They are there. We can't fight out the technology. The simplest way to manage technology is to have more technology. That is how we create the need for technology. So, outside of all this, the first good idea that made us think that we can do a better chunk of testing very quickly are patterns. The gang of four people got together and almost challenged, saying that there will be only 23 such patterns which are very frequently occurring, that facilitates your system, unit, integration, all testings in the field of object oriented. Some of them are architectural patterns. Therefore, object oriented testing definitely is paving way for what we have been always talking about, test driven development. When should testing begin? Analysis and design. Testing begins by evaluating the OOA and OOD models. How do we test OOA models? Requirements and use cases. These are all question marks. How do we test OOD models? Class and sequence diagrams, structured walkthroughs, prototypes, formal reviews, correctness, programming. How does OO make testing different from procedural programming? Concept of unit broadens due to class encapsulation. Integration focuses on classes, validation may still use conventional black box methods. So, you see, the idea of object oriented programming has impacted in this manner. Now, when should testing begin? Should we start with testing? Yeah, if all components are there, why not? At least 20% of the components are already there. Let us start with testing them, whatever is available, then we will build it up. So, these are certain simple thoughts which we have been talking about. Most certainly in the extreme programming world, we talk about test driven programming. This is what I have been talking about, and once we talk about object oriented, we say that there is a reason to believe that XP, which tells that we start at 9 o'clock, end at 5 o'clock, we can 9 o'clock in the morning, end at 5 o'clock in the evening every day. We do not mind throwing away the code, we still need some way to put together what we have done every day as a longer story for a few days. We have talked about sprints, we have talked about epics, we have been talking about so many things. However, as I said, object oriented thrives when we talk about the project mode, something which is developing. Extreme programming has shifted more or less everything into products. If you like the product at the end of the day, it is fine, otherwise we will simply recall that, discard that, build another product. Always rerun all tests, increases every method has its own advantages, its own disadvantages. We need to leverage the advantages. XP is not a silver bullet, it is not a panacea for all problems. Shortened life cycles, we think that even if we go wrong, the cost is not much. It is a limited cost exercise. Promotes validation and reliability, always rerun all tests, increases confidence to change code. What is this curve is something as we go every week, as every week passes, to as we progress more and more towards more number of weeks, the bugs we are looking at every week will lessen. So, you see how the bugs per week increase, that is the nature of software, but once we start controlling them, it remains very stable, very low as we progress into the weeks. So, extreme programming has been exhibiting this kind of a feature which is very attractive. There exists a point in time where we can confidently tell that we will not see any more bugs, they are not likely to increase. Whatever bugs are there, they are there, they are not likely to increase. So, we know how to halt the testing cycle. In theory, yes, it is possible, and object oriented makes it very systematic. It tells us in a larger systemic context, coming all the way from the requirements, integrates well with the business dynamics. We talked about use case driven, we talked about requirements driven. So, we can very confidently tell that beyond this bugs will not occur. There are bugs, we know that the entire process is like that. So, now the concern here is that today everything and anything is appearing as software. Any 10 sentences that make sense, we are calling it software. Well, yes, but programming should be understood very carefully. First, we need to become programmers. It takes 10 years to become a programmer, 10 years to learn programming. So, that is what we have been saying. And criteria for completion of testing, how do we know? This is one curve, XP, weekly testing, beyond a point as the number of weeks increases, the number of bugs do not increase. We do not know what is the complete testing, because whatever we do, only 33% of the code can be called well tested, the remaining 67% as we progress. So, we were hoping that this kind of an observation we had in the extreme programming or now agile world, agile process models, if we use object oriented, we should be able to do it in our regular software development exercise. When are we done with testing? We do not know. Only when the customer puts a gun on the head and tells either you deliver the software, I will not, or I will not pay, we tell that testing is over. 49 different types of testing, all these things we understand. Testing is never done, the burden simply shifts from developer to the customer. That is all we keep telling. At no point in time we can conclude that the testing is over. There is no way in telling that there is no virus in this piece of software, there is no Trojan horse. These are certain things which we can't certify. Testing is done when you run out of time or money, or use a statistical model. So, what we have been doing is just looking at a statistical model most of the times, like the one which we said. Extreme programming is very amenable for a statistical model, object oriented testing is also. So, we talked about the typical, let us say, the reliability engineering in a component manufacturing model. This many pens were on the assembly line, we made this many pens, out of every 100 lot, one is found to be defective, not acceptable, that is too much. Out of 100 lots, not 100 pens, 100 lots of 100 pens, if one is defective, that is acceptable. The progress in the way we make the same artifact multiply, that is how we have been talking about. We improve the industrial process, we improve everything. But what we are talking about is, out of 100 objects required, 20 objects are there. Each time when we are talking about these 20 objects, they came through the testing phase. Therefore, it must be done. These 20 objects we will not test any further. Every testing movement costs. It should come like that. It is sort of a consumerism which is deliberately indicated. The electricity bulb, once it is tested in the shop that is selling. We have to bring it back. If it is working there, it is working everywhere. That is the assumption we are making. Wherever that socket is there, wherever 50 heads supply is there, it is working. So, we have to build that kind of an assurance for all these things. In the world of object oriented, it promises to build that statistical assurance, which is very essential. We are very confident, and most of the times it is working. Well, there are cases, particularly those days when the filament bulb was very important. We had to carry it very carefully, go to the shop. Imagine how you go to the shop and bring the filament bulb after somebody makes you aware that it is a filament bulb. If you shake it vigorously, the filament will break, and if it breaks, all the costs will have to be borne by the fellow who purchased. So, we used to carry it very carefully. Some of them had a mercury inner lining, you can't see the filament, but still you have to carry a filament with a mercury lining. So, we have been talking about the filament, the quality of the filament, the material, tungsten filament bulb that can withstand vigorous shaking. All other filaments are not so good. If you shake it 10 times, it will break. Imagine how it will be. The same thing extends. You have the same degree of confidence in what you are talking about as components. Components should mature like that. So, our goal is to write bug free software. I will pay a $10 bonus for every bug you find and fix. We are rich. I hope this drives the right behavior. I am going to write me a new minivan this afternoon. So, what is it that you can do with a $10 bonus? You will get a software minivan. That much of money will come. Every bug you put $10. As you fix the bug, you get a virtual $10. So, we are rich. So many bugs will be there. Every line out of 7 lines is defective. The programming world, it is bug. Software engineering world is a defect. You can become rich counting the defects. So, we keep talking about the same. Are we building software or are we talking about defects? So, there was a point in time when we talked about defect engineering, almost sounding that we are only injecting defects. What we are engineering are defect engineering. So, lot of terminology, plenty of terminology have happened, and it is a good way of understanding a topic which we call literature survey in academics. Please keep reading, then you would get that kind of an opinion about what exactly is the essence of it. Issues for a successful software testing strategy: specify product requirements long before testing commences. Understand the users of the software. In the traditional model, we had difficulties. Requirements keep on changing, then what are you testing for? Then we said, let there be one requirements verification step. Now, we are not saying that those principles and concepts were not done well, they were done exceedingly well. What we wanted to communicate all along was a practice based process definition. How do you know the process is working? The metrics, the quality frameworks, quality and only quality. So, with use cases, we need to understand these strategic uses, developing a testing plan. So, what we did was, we have been talking about the entire exercise. We have been so enthusiastic in object oriented world because it integrates, as we kept telling, that systemic, unit and the integration testing are seamless, and we keep talking about doing this each time, anytime and everywhere. A rapid cycle testing, build robust software that is designed to test itself. These are all some very good ideas. So, conduct formal technical reviews to assess test strategy and test cases, who watches the watchers. All these are very important ideas which are not so outlandish. We all talk about it. But now, what is the concern here? The concern here is that we need to prepare for that kind of a testing properly. Once again, we take recourse to what is called UML and the testing notation. We have the simple testing notation capturing all the classes and operations in UML diagram. Testing for analysis and design testing, ADT is analysis and testing design. Testing for consistency, an inconsistent model has representations in one part that are not reflected in other portions of the model. So, what we need to do is, we have been talking about complete model testing, total testing of each component. All these things were happening, but initially when we began using UML, the proof of the pudding is the deployment. Gradually we lost that particular idea of deployment, saying that right at the beginning I know that this piece of software should work here. We have relaxed it. We are not able to do that with that kind of a consistency. Once we have relaxed that, the proof of the pudding once again moves into all those pluses and minuses of what we called testing for consistency. That is how we have been talking about testing the class model. We started doing, let us do it in the middle, revisit the use cases, CRC cards, UML class model, everything we wanted to do it like what we were doing the traditional testing, but with a difference, as we have been discussing in this set of lectures. Have you tested your analysis and design? If not, who will do it? So, the testing OO code implies all of them coming together: class tests, system tests, validation tests, integration tests. Minimum these 4 varieties of tests must converge on a given OO code. There are, as I said, 49 varieties of tests. If you are doing a good testing of the OO code, class tests, integration tests, validation tests, system tests must all converge on that OO code. Only then we can tell that the testing is happening. How do we build that? What are we going to do? This is what is the concern. Smallest testable unit is the encapsulated class. Test each method, test the state behavior. How do you know? How do you test a class? That is the question that is being asked. Forget about converging 4 types. How is class testing different from conventional testing? Conventional testing focuses on input, process, output, whereas class testing focuses on each method. This is what I have discussed earlier on, that we bank the object orientedness of testing on those 3 foundational concepts called polymorphism, inheritance and encapsulation. There is no reason to think that it does not work. It is lot more easier to pin what object is going wrong. More important, it is very natural because it appears broken systems. It localizes the fault, it localizes the change propagation. It is easy to understand so many things. We design like that, we have to localize the fault as much as possible. So, we talked about black boxes, class testing, class to be tested, software engineering is like this, test cases are there. So, this goes on and on and on, we keep on giving results. So, what is it that is seeking completion of the test case? When do we know that the testing is complete? So, on class test we can't conclude. If system test, integration test, validation test, other 3 things come together, we can conclude. When they converge, we can conclude, yes, we have done adequate testing. Same old questions will happen, but object oriented gives us this possibility that if you can have 4 different tests converging, we can draw a line and tell that this has been done. Otherwise, testing cycles go on endlessly. We have done up to 300 lines, add 3 more lines, make it 303, 303 is a good number. So, make it 303, you have to redo everything that you did for 300 lines of code. Just because we added only 3 lines, that is 1/100th of the length of the original lines of code, it does not mean it is just one more simple test case. You have to repeat the entire exercise, whereas in object oriented testing we get an assurance thanks to the patterns, thanks to so many things, that it is possible that if class tests, system tests, integration tests and validation tests, if all of them converge, then we think that it is done adequately. State the purpose of the test, each test should contain, this is a test documentation, we need to do that. Challenges of class testing: encapsulation, difficult to obtain a snapshot of a class without building extra methods. Same encapsulation, inheritance, polymorphism, which I have discussed earlier. But what is it paving way for? It is paving way for what is called a test based approach to the entire object oriented analysis and design. Black box and white box, the random class testings. You do not have to test every class, you do not have to test every aspect of the class. It is now statistically amenable. Then we talked about integration testing. OO does not have a hierarchical control structure, so conventional top down and bottom up integration tests have little meaning. In the original traditional mold, the integration testing was banking on top down and bottom up. Now it is not there, they blend seamlessly. So, systemic integration is more systemic. So, you have to converge that. Use based testing, thread based testing, cluster testing, different varieties of that. A random integrated testing is quite possible. Validation testing: is it what the user needs, the external quality factors? Are we building the right product? That is the question we are asking. Validation succeeds when software functions in a manner that can be reasonably expected by the customer. We need to understand that focus on user visible actions and user recognizable outputs. User plays a central role. This we can bring in very early. Even though it is a makeup kit, the powder speaks for itself. The face powder here is adequately tested for the purpose, and I know how to use it, I can attest very quickly. If it is going into the kit, I know it is all done, it is tested and they do not mingle in the kit. So, we are all right. Details of class connections disappear at this level. So, what we have done is use case scenarios from the software requirement specification, black box testing to create a deficiency list, acceptance test through alpha testing, beta testing. These were very common exercises which we have been talking about. So, those of us who have always been working in this open source world, we have been telling that it is a bit going through a beta. So, it takes time, there may be still several bugs. Acceptance testing is something that is done by people who are clueless about the development and the technology. The software is not 100% complete. If it had a user interface, you would see something here and sometimes there, and then you would be saying I gotta get me some of that, any questions. This is all we can tell. So, you see how simple it is. The software is not 100% complete. If it had a user interface, you are imagining you would see something here in this corner, sometimes there or sometimes here, and then you would be saying I will have to get something of that here. There are any questions? Acceptance testing is more or less like that. We wish that it is like that. Most of the times acceptance testing is a euphemism to tell that at least the basic things are happening. Basic handful of tasks which 20 different people were supposed to do are happening. It does not mean everything else is happening. So, we keep telling that it is the burden of both the developer and the customer. Systems testing: the fourth, software may be part of a larger system. This often leads to finger pointing by other system development teams. We cannot escape, it is part of a development exercise. Most development exercises tend to be like this. Finger pointing defense: design error handling paths that test external information, conduct a series of tests that simulates bad data, record the results of tests to use as evidence. So, this is how we have been talking about types of system testing: recovery testing, security testing, stress testing, performance testing. To a limited scale, object oriented is very clearly telling that this much you can recover in half a second. Security testing tells the critical components are all well tested and made to happen. Stress testing, performance testing. Redbert, my company is hiring for our quality assurance group. You would be perfect. What would I have to do? You would find flaws in our new product, thus making yourself an object of intense hatred and ridicule. but then you would fix those flaws and your respect for me would grow into a special bond of friendship. No, then we ship. We don't part as friends. After Radbert finds all problems, Radbert will still remain as somebody who is most hated and ridiculed, because the maximum number of faults have been found. So, because of this, we have been talking about that quality assurance group, software quality assurance teams as people who are like that. They write nasty reports. Can we do better? Object oriented appears to be doing well. Testing affects all stages of software engineering cycle. One strategy is a bottom up approach, class integration, validation, system level testing. The XP advocates test driven development, plan tests before you write any code, then test any changes. So, you write code as per what you have envisaged as testable, white box, black box, debugging. In conclusion, object oriented testing levels unit, system and same as traditional levels. Object oriented integration testing is different and more complex. Optimal test order saves lot of money. How do we order the tests? That's the second question. We cannot do some random sequencing of testings. There should be a way in which we sequence the tests, optimize that. Tools required to scale up object oriented testing, limit designers to straight inheritance, no redefining, that is base classes are there, inheritance classes are there. Let us not do more than that. So, single inheritance, multiple inheritance, these were certain ideas which were explored. Some languages have multiple inheritance, some languages do not have multiple inheritance. If the languages do not have inheritance, they become object based languages. So, whether it is object based as object oriented, the concept of object, the concept of a class which we have been discussing over the last 40 plus lecture sessions are essential in understanding why the object oriented paradigm was thought of and why so many thoughts put together are expected to help us build complex software programs and systems with more confidence, with lesser defects, and as they evolve we are not really perturbed, we will simply occlude more and more features, more and more functionalities. The requirements are still unstable. Even today 70% of the requirements change as we progress, but we have learnt through object oriented programming how to scale, how to work with business driven, use case driven approach, and what we have therefore been talking about is a way this paradigm has impacted the entire software engineering to a point where object oriented software engineering with some very unique ideas has come into the place of software engineering workspaces. And when we talked about all these things in software engineering workspaces, we found that it is a completely different way of thinking. We need to change the way we have been thinking. We need to understand that even though all pieces of software are equally tested or equally untested, whichever way you want to look at it, we need to make sure that we have a way of using object oriented as a technology option to make all of them work to a point where that 36% success rate appears doable, achievable. Most of the works which are touching 36% of success rate are banking on object oriented tools, object oriented analysis and design. It is a very important subject. Next, we have been talking about the next 2 decades of software development will be impacted more because of these ideas, from objects to things. We talked about service oriented architectures, but in the world of things we have difficulties. Object oriented is more promising. Again, I am not saying that this paradigm kills other paradigm, this paradigm is unique, this technology kills other technology, that is not the idea. The more you have technology, the more it demands from you. that is how it is from people. Therefore, we have to manage technology by making better technology happen. That is the way in which we use technology and thrive on technology. Thank you. We will meet later for some other lecture session. Thank you.